Okay, by now the students are very well aware of the fact that this trapezoid method of getting the area under this curve provides a very unsatisfying answer to the question of what is the area under the curve. In today's lesson, I want to promote some mathematical thinking and some mathematical creativity by having students choose a variety of methods of their own thinking of how to minimize that error. This allows students an opportunity to demonstrate one of the science and engineering practices, which is to use mathematical and computational thinking, and also one of the Common Core math practices, which is to be able to model with mathematics and to kind of be able to work creatively in mathematics. Here's an effort that ultimately fails, but provides some a great bit of thinking on the student's part. They want to slide down the line, so fixing it on this end, on the end that is marked B, fixing it there, but then sliding it down on this end, so they traded off some of the overestimation for some underestimation. The sort of obvious visual appeal is that trading those off, there's probably some place where that ultimately would cancel just perfectly, but here's where it falls down. They're not sure where to draw the line to, other than to kind of visually estimate it, and hence this idea, this naming of the force, the height of this part of the trapezoid as F hunch. Here's a second idea that's very appealing. This is a student showing 4 trapezoids instead of 1, and everyone can appreciate the idea that the big area that was covered or gathered by the single trapezoid is now broken up into 4 smaller areas, and that's a huge step in the right direction. Finally, this might be my favorite one, although it's sloppy and a little bit hectic here. The 2 lines to concentrate on are this sort of red line here that the students drew tangent to the midpoint of the curve, and the original line here, which was the single trapezoid method. The students want to get 2 areas, the original single trapezoid area and then the second single trapezoid area, which is underneath the curve, or with the line tangent to the curve, this one right here again, and average those 2 areas together. I like this one a lot because it's, although a little bit sloppy, it provides a rationale for where to draw that second line if one was going to try to trade off some underestimation for an overestimation. And finally, as a last thought, I just want to share that none of these examples were done computationally. They were all done fairly qualitatively and kind of looking at it visually and thinking about the pros and cons of the suggestion without getting hung up in the computation, which I think is a really advantageous part of this exercise that kind of helps students be creative and thoughtful and somewhat playful with their mathematics.